Narsimha Omar. All right, great. All right, today we will start trying to understand a little more about HANA. Today's session and tomorrow's session also will be 1 hour, but from the next week on we will have longer sessions, and over the weekend we will have a couple of sessions. So let's try to understand a little more about HANA. All right. All right, yesterday we have discussed a little about HANA. We talked about HANA as an in-memory database, a hybrid database. I told you that there are majorly two different approaches for SAP HANA. One is an appliance and the second one is a database. So this training we will start off in the beginning with SAP HANA as an appliance. All right. You know that HANA basically stands for High Performance Analytical Appliance, or the in-memory server. Now, the basic roadmap for SAP HANA is depicted in this picture. You would have SAP HANA positioned as a standalone system, and you would have data coming in from multiple systems. You could bring in data from the SAP business suite, which comprises of ECC or CRM or SRM systems or any other BW systems. You could also bring in data from multiple databases. You could bring in data from, let's say, flat files. All of these are brought into the SAP HANA appliance. The appliance is a combination of software and hardware components. The hardware provided by SAP's partner vendors, they help create these servers, and the software is provided by SAP itself. The interface for the software is called as SAP HANA Studio. We will be looking at that and trying to understand what are the components and what is the new terminology in this interface as we go along in this training. So if you remember yesterday's session, I've told you that SAP HANA basically is a database, all right, and it cannot generate data on its own. You will have to enable it to bring data into it, either through an application or either through process. You need to bring data into SAP HANA database. Now, once data is generated on your transaction systems, usually you don't leverage analytics on the transaction system because it might cause a little hindrance, or it might cause performance issues. So you want to handle all your analytics on a separate system. And that's when BW came into picture. But SAP HANA is basically a bridge between the transaction system and the analytics system. Now in SAP HANA, the servers are extremely fast. You have a lot of components that enable you to do very fast calculations over huge amounts of data. And that's why once data comes into SAP HANA, then your processing is very fast. You are able to give out data and results at a very fast pace. But the challenge here is, apart from able to calculate, apart from able to generate data into reports, the biggest challenge here is to make data available from the business transaction systems into the SAP HANA appliance. All right. So there are multiple ways that are provided for which you could go ahead and bring in data from SAP's business suite or non-SAP systems into SAP HANA appliance. The HANA appliance is not only for SAP systems, but non-SAP systems also could leverage the speeds of SAP HANA. So there should be a mechanism through which you are able to bring in data from the BW or SAP business suites or BW system, or you could even have non-SAP systems through which you can bring in data into SAP HANA. Alright, so here there are multiple options that you have, and this is called as data provisioning. Alright, data provisioning is a method to enable different engines to go ahead and bring data from SAP and non-SAP real-time speeds into SAP HANA. The SAP HANA box is enabled for calculation. That doesn't mean that you want to bring in data and start cleansing data inside SAP HANA, trying to calculate data inside SAP HANA. So the principle is that if possible, the data provisioning engine, whichever is providing data into SAP HANA from the source system, can cleanse data as it pushes data into SAP HANA, or it has the ability to transform data before you actually send it to SAP HANA. Alright, there are four major ways as to how you can push data into SAP HANA. One of the most used methods are the SLT, SAP's Landscape Transformation Server, Data Services, BODS, Business Objects Data Services. The third is DXC, Direct Extractor Connection, and the fourth is Sybase Replication. Alright, there are four different ways as to how you can go ahead and bring data into SAP HANA. Each of these are used at different scenarios depending on the kind of source that you're using and the urgency at which you want data at the SAP HANA box. Some of them are real-time, some of them are near real-time. We will talk about those data provisioning methods as we go along. All right. The fourth type of extraction, or the fourth type of replication, is called as Sybase replication or log-based replication. All right. All right. So like I told yesterday, SAP HANA doesn't have its own proprietary reporting tools, so it uses usually a suite of business objects reporting tools or MS Excel, or it can use other reporting tools on top of SAP HANA like Lumira, Visual Intelligence, Predictive Analytics. All of these you would have on top of SAP HANA. Any one of you having, I hope all of you are able to hear my voice clearly. Please let me know in case there is any breaking of voice or stuff, alright? Alright, so if you go a little further on. So SAP HANA is a flexible data source agnostic appliance that enables customers to analyze large volumes of data. Narsimha Rao, you have a question?
The voice is breaking up. I cannot hear it. I can hear only part and parcel of your statements.
Okay. Guys, is that the same for everybody?
It's not consistent. Sometimes it is breaking up. Sometimes it is more audible.
All right. Can you give me just 2 minutes? Let me just log back in.
Okay.
All right. All of you, can you just hold on for a couple of minutes? Let me just join back in. All right. Hello? Guys, are you able to hear me clearly now? Hi, Narasimha, are you able to hear me clearly now? Okay, great.
Yes.
All right, so just reflecting back on what we were talking about here. Now, SAP HANA is a flexible data source agnostic appliance that enables customers to analyze large volumes of SAP ERP data in real time, avoiding the need to materialize transformations. So the best part about SAP HANA, or uh, in, in comparison with what we have in BW, is we are not going to have multiple layerings with holding data at each transformation, but you will be creating views which will be only structures that will only consume the actual tables at runtime, but you will not be actually storing data at multiple layers. All right, and you are able to connect to multiple different data sources and bring data into SAP HANA appliance. The SAP HANA is a hardware and a software combination that integrates a number of SAP components. All right. So going further on, what SAP HANA basically is you have the entire database in the RAM, or you're storing the entire database on the RAM. It's as good as you are able to bring data at extreme speeds because you're storing data and accessing it from the main memory. All right. The traditional approach is you have a database or a hard drive, and you're going to bring data from that into the application layer and process the data, and then you get the result. But here you have the entire database on the RAM, and your calculation is actually pushed down onto the database itself. So you have extreme speeds at which you can provide the data to the reporting layer. Your calculation speeds are extremely high. Also, you have, if you have heard about column storage, there are two basic storages that we're going to use within SAP HANA. One is called as the row store or row-based storage, and the second one is called as column storage or column-based storage. Now, this is going to be one of the main features through which you are able to give data out onto the reporting at extreme speeds. Uh, The reason for that is that the system, now the traditional approach of how the row store is just like how we usually see data on normal databases. That is, in case you're trying to fire a query, the system has to go through every single row completely from left to right. And once it completes, it has to come back to the beginning. Now I'll show you a small snapshot of what I'm talking. So if you can see my screen, the traditional approach when you read a query is you start off from the left, go on to the right, and then come back to the beginning of the next row, and then you read, though your result is not found in there. Let's say you're looking for a material with material number 3, all right? So if a query is, I want to see the customer name with material number 3, or I want to find out customer number 4, the system has to read through from left to right till it gets to this particular row. Whereas when you are looking at SAP HANA, you are looking at column storage. Each column is divided as a single table, and you are connected to individual columns using an index. So you are trying to read data from top to bottom, or a vertical read, which enables you to bring to the result much more quickly than the row store. All right. So we'll try to understand the column store as well. And this is the technology that is used within the SAP HANA database. All right. Yes. Narasimha Rao, any question again?
No.
Okay. You are able to see my screen, right? Because Omar mentioned he was not able to see the screen.
I can see the screen. Your voice again, sometimes it is breaking.
Okay. All right. All right. Let me repeat about this column store because yes, they're asking again. Now I'll give you an example. All right. So here is an example of a table. Okay. You can see this table which has basically. Just give me one moment. All right. So you can see this table which has 4 columns and you have 4 rows. Okay. In the traditional approach, each row is called as a tuple in the row-based storage. Okay. So you call tuple 1, tuple 2, tuple 3, and tuple 4. Let's say I fire a query saying that I want to look at the amount spent by customer 300. Okay. Now, in the traditional approach, what you will be doing is you first start off with row 1. The moment you come here, the query understands that this is not the customer we're looking for, but it doesn't have an option. It has to read through the entire row. All right. Then it crosses the second or the first row, and it has to come back to the beginning of the second row. It has to read through the entire row even though it knows that this is not the customer we're looking at. Then it has to come to the third row and read through the entire row. When it comes to the fourth row, this is the customer it is looking for, and it's able to bring this to the result of the query. Whereas in the column storage, if you consider this to be a table, it has 4 columns. In the column storage, each of these columns are stored as a table and they're connected using an index. Alright, so, and there is very high compression ratio here. You will not be repeating the values in here. In the first table or the first column, you have 3 values. Though customer 100 is coming up twice, you will find that it is 100, 200, and 300. If it is country, you find only 2 values, Germany and US. Even if it's product, it has 2 values, 1 and 2. Only the amount is the one that's going to occupy all of the different columns. So there is high compression ratio when you are using column storage, and when you're trying to read data, it is going to read from top to down instead of left to right. So you come to your results much faster than what you do on the row store. So if you're looking at column 1, so it is not 100, it is not 200, so the next option is 300. By the third iteration, you are able to find out that this is the customer that you're looking at. It indexes the remaining columns and then it brings the result onto the query. Alright, so the column storage is extremely fast, and the advantage is the system stores data in 2 instances. One is row stores and the second one is column stores. The row stores enable you to handle inserts, updates, and deletes, whereas the column store enables you to pick the data extremely fast. Alright, for most of the searches, you will find that it is using the column storages. Alright, so that is basically the advantage of having column storage on SAP HANA. Getting back to what we were looking at, the storing data is entire database is on the RAM. You can combine row stores and column storage in one database. Acceleration of data intensive processes and make decisions at real time because you are able to bring data into SAP HANA at real time. And fourth one, the analysis is unprecedented insight into data and bringing together the worlds of OLTP and OLAP systems. So that is what HANA is aimed at. Now, I've been talking about HANA as an appliance, and it is basically a combination of the I am cutting off again, is it? Yes, is this for everybody or is it? Hi, Omar. Is this pretty bad, or I don't know? I have even changed the network, so I'm just wondering. Chandra. All right. Okay. Just to move a little forward. Now, I've been talking about SAP HANA as a combination of hardware and software, and we want to see what are the innovations on both the hardware side and the software side that enables SAP HANA to be extremely fast. So here are a few of the reasons why SAP HANA and the innovations from hardware and the software technologies. Now, from the hardware technology, you have multi-core architecture on SAP HANA, massive scaling using blade servers. You have 1 TB, a minimum of 1 TB RAM servers. The throughput is extremely high. Significant reduction in price and performance. Now, you must have heard of you have your laptops, right? And in your laptops, usually what we have is dual core processors. Now, the first time around when they came, you had single core. A core is the intrinsic part of the system that handles calculations and what you do on the application layer. Now, if you have a million rows of data and you're taking an hour, or let's say you're taking an hour to process that, if you have on the CPU, if you have dual core, meaning two cores, the entire process is divided into two major areas, or you can split the entire process into two separate cores and they can parallelly process the whole thing. So a million records which was taking an hour to process, if you have dual core, you're going to process it in half an hour. All right, because you're able to process the same amount of data using two processes which are sharing the entire calculation. Now, if you have a quad core, meaning 4 cores on one CPU, then you are slicing the time by 4 times. Your entire process of calculation is split among 4 different cores. Now, what we have, or where we are at right now, is one CPU is able to accommodate 10 cores, meaning the parallel processing is 10 times. So what was taking 1 hour, if it was on the same CPU that you are using right now, can bring it down 10 times, meaning it takes 6 minutes to process the entire thing. All right. Now, before we go and try to understand the blade service, let me show you one more slide. All right, so the CPU is able to accommodate 10 cores is what I told you. So the parallel processing is right now 10 times. Now you have something called as boards. The boards can accommodate multiple CPUs. And let's say we can accommodate 8 CPUs on one board. All right. So each CPU is having 10 cores. 8 CPUs on one board is 80 cores. And such kind of boards, you can accommodate at least 4 on a blade server. So you're looking at somewhere close to 320 cores on one blade. all right, and the amount of RAM that we're using is from 1 TB to 4 TB RAMs or more, all right. So the amount of parallel processing that we are using with SAP HANA is extremely high, and so the throughput and also the processing speeds are very high when you're using it with SAP HANA. Alright, the network also is very fast. You have throughputs of 100 GB per second. So you're able to transfer data from different systems into SAP HANA at extreme speeds as well. And since the memory's price has come down, you could use higher memory as well. Now we've talked about the hardware side of it. Let's also try to understand the software side of it. You have a row and column storages. Just now we've talked about row and column storages. You have partitioning as an intrinsic part of how data is pushed into the system. You have a very high compression ratio, and then there is no need for aggregation tables. It is automatically aggregated. So these are the advantages from the software side, and it's a combination of both hardware and software. Now there are different kinds of clients or enterprises which would want to use SAP HANA. So it is not that one server fits all. There are different kinds of server sizes. There are different kinds of ways how people would want to use SAP HANA. Some of them might be already customers with SAP. Some of them might want to use the capability of SAP HANA, though they are not SAP customers. Now, how is SAP able to cater to all of these different kinds of clients? You have three major editions on the software. It's called Platform Edition, Enterprise Edition, and Extended or Enterprise Extended Edition. The Platform Edition is specifically for SAP customers, already existing customers who have licenses, and the core components that you have from SAP HANA is the SAP HANA database, the SAP HANA Studio, the SAP HANA Client, SAP Host Agent 7.20, SAP HANA Information Composer. These are the core components that you get along in the Platform Edition. Alright, this is for customers who are already SAP customers. If you are an SAP customer and you also have licenses with Sybase or data services, then you don't have to buy any additional licenses for LT replication, data services, and the Sybase replication server. So the core components is what you would want to use, and they are packaged as the platform edition. Now going to the second type of edition, which is called as the Enterprise Edition, in which you have the core components of SAP HANA, plus you have the LT replication licenses and data services licenses packaged alongside it. So this is for customers who want to use the core of SAP HANA and also who need to have licenses for the replication engines like the SLT and data services. Enterprise Edition also is for SAP customers only. Alright, and if you're not an SAP customer, the edition of software that you use is called as the Enterprise Edition or Enterprise Extended Edition. In this edition, you have almost all the components packaged so that the customer is able to use SAP HANA with his own system, with his own transaction system. It could be a database, it could be a web services system, it could be a non-SAP system, but here you have adapters and licensing for using all of these different engines to link your transaction system with SAP HANA Box. So for these kind of customers, the package includes the core SAP HANA components and also licensing for the replication engines. Now coming to the most important part of today's session is the architecture of SAP HANA. Now this is the architecture of SAP HANA, and here you have majorly the system or the architecture is divided into three major sections. Alright, so here is the core of SAP HANA, and it's divided into three main sections. Okay, the first section is called as the data provisioning. All right. The second section is the in-memory computing engine. The third section that you have is the modeling section. Okay. Now, the section which is called as the data provisioning section allows you within the architecture to connect to multiple systems. It could be an SAP system, it could be a non-SAP system, it could be a flat file, it could be a database, it could be a web service. So the ability for different systems to be able to connect to SAP HANA and replicate data into SAP HANA is the most essential thing. And this is at layer 1, and this is called as data provisioning. Here you have in this slide, you have three major data provisioning engines that are listed down. The first one is called as real-time replication services. This is also called as Sybase replication or log-based replication. All right. So here you would have data replication from database to database into SAP HANA. The logs are converted into transactions, and this is extremely fast, and it is called as the real-time replication. So the only downside to this replication is it cannot handle transformation. So in case you want to handle any kind of calculation using the data provisioning engine before you send it into SAP HANA, it is not possible here. You can only directly push data into SAP HANA by replication using Sybase. The second kind of replication engine, which is the most commonly used, which is called as SLT. SLT stands for SAP's Landscape Transformation Engine. All right. Now this is an engine which basically allows you to connect to SAP systems and also a few databases. So you are able to connect to ECC, CRM, SRM systems, and you are able to replicate data at real time. It also has the capability to transform data before you send it into SAP HANA, but it requires a little ABAP knowledge to go ahead and handle conversions and handling of transformations before you send data into the SAP HANA. The SLT system basically is a real-time replication engine. It is majorly used when you're trying to do client copies and system copies in ECC, but now it has been leveraged to use it for real-time replication into SAP HANA from all SAP systems and a few databases. All right. So this is directly interfaced into the SAP HANA Studio interface as data provisioning layer. So when you click on data provisioning in the SAP HANA Studio, it will link you directly to the SLT. All right. This is a real-time replication engine and also supports a little transformation processing as well. The third kind of replication engine, which is called as data services, you also call it as the ETL replication. This is the only ETL tool through which you can connect different systems into SAP HANA. This enables you to allow and connect almost every system into SAP HANA, both SAP and non-SAP. Data services is one of the ETL tools that is very predominantly used within the SAP landscape nowadays. This was actually bought by Business Objects from and then it is used now after SAP acquired Business Objects. It is also acquired data services, so they have changed the architecture a little bit and then they call this as Business Objects Data Services. It is used as the only ETL tool through which you can bring data into SAP HANA box. All right. So it has a tremendous capability for transformation. The tool also has the cleansing or quality transforms along with this so that you enable it so that the best and the highest quality data can be moved into SAP HANA. All right. The transformation is very simple that you can handle in data services. The only downside to it is this is not real-time replication, but it is called as near real-time replication. So you schedule the jobs multiple times in a day so that you are always updated with the latest data into SAP HANA. So that is the third kind of replication. The fourth kind of replication is called as DXC, direct extractor connection. You would be using native to connect the persistent staging layer directly, persistent staging area directly into SAP HANA box. We will talk about that once we get a little idea with BW. All right. The second layer that you have is the in-memory computing engine. Right. So the in-memory computing engine is the heart of the entire SAP HANA appliance. It consists of two major blocks. One is the calculation and planning engine. The second one is the row and the column storage. The calculation and the planning engine basically help with the calculation of data. All right, the fourth option, Narasimha Rao asked what is the fourth option. The fourth option that I was talking about is called as DXC, Direct Extractor Connection. All right, so what you have in DXC is you have, all right, all four of them. I'm going to repeat all four of them again. In the data provisioning layer, the first one is called as real-time replication. The other name for it is log-based replication or Sybase replication. This enables you to replicate database to database. All right, this is not a usually used replication method, but you can enable to use Sybase replication. This is when you want to move data from one database into SAP HANA database, so you use Sybase replication, and this is specifically done by SAP itself. All right, so this is not a very regularly used process. The only downside to it is it cannot handle transformations. All right, it is direct replication into SAP HANA. The second option that you have is SLT, is called as SAP's Landscape Transformation Server. Enables you to connect all SAP systems into SAP HANA. It is a real-time processing system. Also enables a few databases to connect into SAP HANA. The third kind of replication is data services replication, which is called as the ETL replication, or you also with data services, you have the ability to replicate data from any system. It could be an SAP system, it could be a non-SAP system, it could be a database, web services, name it, and you are able to connect. This is the only ETL tool that can connect to SAP HANA. All right, and here the tool is enabled. Yes, Sybase also is a real-time replication server, but it is specialized to replicate data from databases alone. All right, the question is, so Raju is asking, what about Sybase replication server? Is it the same as real-time replication server? Yes. Sybase or real-time replication server is in fact a very fast replication, and it is real-time. SLT also is real-time replication server. Data services is the ETL replication, and you're able to replicate data. So the calculation engine, basically you find it as calculation. It's basically not just arithmetic calculation, but you have different queries coming in from different, it doesn't have a proprietary reporting tool, right? So you have queries firing in from different reporting tools, and these are actually converted into the native SQL of SAP HANA database, and this is also a part of the calculation engine. Alright, so it calculates and it translates the data from, let's say, MDX, SQL, BIX, and it converts that into native SQL, breaks down bigger queries into smaller queries. All of that is handled in the calculation and planning engine. It is able to support also a few financial planning applications on top of SAP HANA. So you have the planning engine as well. The second box that you have here is the row and the column storage. the two different instances as to how data is stored, and all of this is there on the RAM itself, the main memory. So you have a lot of functions and procedures that you can apply here on the data, uh, on the in-memory computing engine as well. The top of the layer you have the modeling studio. Now you're going to use the row and the column storage, uh, columns and rows and tables that are here in the modeling studio. Once you define a view, the objects that you have in the modeling studio, these are called as the views, all right? And here these views can be the ones that can be exposed to the reporting layer. The modeling studio basically consists of the attribute view, the analytic view, and the calculation view, along with a few procedures and decision tables that you can create. They will channelize and use the tables that you have in the row stores and the column stores. The views basically do not hold data at any layer, but you will be consuming them at runtime. The reporting tools will use the column stores, and that enables them to be able to bring the report much faster because it's searching through the data that is there on the SAP HANA box. Alright, it doesn't have a proprietary reporting tool. It uses different SAP, usually business objects, suite of reporting tools and other applications that can be leveraged on top of SAP HANA for reporting. Alright, so this is the basic architecture of SAP HANA. You should have a high-level understanding about this. Alright, in tomorrow's session, what I am going to tell is once we understand what do we have in this major engine, in-memory computing engine, what happens at the database layer. Once you move data into SAP HANA, how is it processed? What are the different layers? Because it is not, though we call it as HANA server, it is not one single server. It has a lot of different servers. The database itself is divided into multiple servers for handling searching, for translation. Right? There are multiple servers that are inside the SAP HANA in-memory computing engine. So we're going to look at those engines and the different servers that are there on the SAP HANA server. All right. SLT means SAP's Landscape Transformation Server, not Sybase Landscape Transformation. All right. All right. So I will stop the session today at this point. All right. We will continue in tomorrow's session. If you guys can come by 8 p.m. EST, all of you, if you are available by 8 p.m. EST, just for one more day, we can do longer sessions. All right, just bear with me for another day to do a 1 hour session. So once we complete that, we will be able to do 1.5 hour to 2 hour sessions regularly. All right. I hope you are able to follow the pace at which I'm teaching. In case you have any feedback, please do mention it to the organizers. All right. So this is basically the understanding of the architecture. For this week, we will have sessions on the weekend, but again, from the next, it depends on all of you. If you would want to do weekend sessions or if you want to do only weekday sessions, all right? This weekend, we will have weekend sessions. I want to bring you up to speed on some of the HANA topics, so we will be doing weekend sessions for this week. All right, only for this week. The next weekend, I don't think we will be doing. Yeah. So this is the first class, and we're just having a little exposure to SAP HANA. We will go into a little depth into SAP HANA and the HANA in-memory computing engine in tomorrow's session. All right. All right. I have unmuted you, but I think it's you've joined in from the call. Narsimha Rao, I've unmuted you. It says audio pin sent. You've connected through a different method. Alright. So I will see you guys tomorrow at the same time. Today we started the session at 8 p.m. EST. Try to be there on time. And then we could Narsimha Rao, yes, you could type that question because I'm not able to unmute you. Yeah, I think you could now speak. Yeah, go ahead.
Can you hear me now?
Yeah, go ahead.
Yeah, can you hear me?
Yeah, go ahead.
Okay, so the BW on HANA versus just a standalone BW, what is the difference in the course content?
Uh, we're going to look at a lot of in-memory BW cubes and the architecture of the DSO, because what I teach in the core BW, that will not be applicable in the BW on top of SAP HANA, because the database is changing and the architecture is changing. So we'll be looking at that, understanding the in-memory objects like the info cubes, the DSOs. We will be looking at understanding the core replication into SAP BW on top of HANA. We will be looking at moving objects between BW and SAP HANA, how to move let's say the views from SAP HANA to BW, how to move info cubes and DSOs into SAP HANA, into HANA Studio. We will be trying to understand how to bring data from SLT into BW, and there are a lot of other topics also listed in the course content. I believe you must be able to access the course content, so you can take a look at that.
Okay.
Yeah.
So in order to do the BW on HANA class, should we have to have the complete BW class?
Yeah, we will be looking at core of BW, and then we will be looking at BW on top of HANA. That makes it easier for you to understand.
Okay, so will you be giving differences? Like if it is not a
Yes,
HANA based BW,
absolutely,
what if
absolutely.
you know, COPA extraction or LO cockpit extraction, all that. Will you cover all that stuff?
Yes.
Okay. Okay, thanks.
All right, guys. All right, guys, I'll see you around tomorrow at the same time. Please be there on time, and then we could do a complete session. All right. Thank you for it. Take care and have a nice evening. Bye, guys.